Hello, general psychology students. So the purpose of this video is to cover chapter 5. So we're in week 3 of general psychology. In week 1, we covered chapter 1 on the history of psychology and chapter 2 on research methods. Then in week 2, we covered chapter 3 on the brain and behavior. And now this week, week 3, we're covering chapter 5. Notice how we're skipping chapter 4. We'll get back to that on another unit. Next week, week 4, you'll have your exam, your first exam in the class, and it will cover chapters 1, 2, 3, and 5. Okay, so the purpose of this video again is chapter 5, the chapters on sensation and perception. So let's get to it. I'm going to start by sharing the screen, share screen with the PowerPoint slides. And remember that these PowerPoint slides are available in your course content and Unit 1 materials. There's a section that says PowerPoint slides. If you click on it, there are 4 links. The last link is Chapter 5, Sensation and Perception, and this is where you'll find them. All right, so let's get to what do we even mean by the term sensation and perception? So sensation is the activation of our sense organs, our ears, our mouth for tasting, our nose, our eyes, our skin for sensing pressure and feeling things. It's the activation of these sense organs by a stimulus. So light waves come and activate our eyes, sound waves come and activate the nerves in our ears, skin pressure on our skin. So sensation is the process by which sensory information is detected by our sensory receptors. Now, how does this exactly work? Well, it's a process that we call transduction. So transduction is the conversion of the sensory stimuli, so like light waves, sound waves, skin pressure, okay, of the sensory stimulus energy to action potential. Now remember when we talked about in the last chapter, in chapter 3, about what action potential is. So remember, for the neurons to communicate with one another, what's going to happen is one neuron is going to get a sensation from the neuron before it through the dendrites. Remember, those dendrites are those like tree-like, branch-like features at the very beginning. And if enough of the neurotransmitters activate enough of these dendrites, then the message will be sent to the cell body, to the soma, that says action potential. There's enough here to activate it. And an electrical signal will be sent down the axon. Remember, that axon is covered by that bubble wrap thing, the myelin sheath. And the thicker that myelin sheath is, the faster that the impulse, the electrical impulse will go down that axon. At the very end of the axon are those terminals, and at the end of the terminals are terminal buttons. And if once that, using that all or none principle, once that neuron fires, and so the electrical impulse is sent to the end, once it gets to that terminal, then the neurotransmitters, those chemicals that are in the terminal buttons, will sort of ooze out into that synapse, that space between the terminals of one neuron and the dendrites of the next neuron. And in that synapse, in that space, that chemical sort of oozes or floats out. Some of that chemical will reach receptors on the dendrites of the next neuron, and they'll fit like a lock and key. And some of those neurotransmitters and those lock and key systems work where it's more likely to excite the nerve and the neuron and make it fire. Some of it actually subdues it and makes it less likely. It's an inhibitor. It inhibits the likelihood of the next neuron firing. So, but there's either enough to make it fire and it fires, or there isn't enough and it doesn't fire. So it's not like it fires on a graduated scale. It either fires or it doesn't fire. Okay, but this transduction, this is the conversion of that sensory stimulus energy to the action potential. So that action potential is the thing that's going to make that neuron fire. Okay, and then we've got perception. So perception is the interpretation, analysis, and integration. It's the assigning of meaning. of all of those sensations. It's the way sensory information is organized, interpreted, and consciously experienced. So if I were you, I'd be asking the question, can sensation and perception exist without one another? Yeah, they can. So think about this piano player. If you're standing in the midst of this street scene, you'd be absorbing and processing numerous pieces of sensory input, but you're probably only perceiving a much smaller portion of it. It would be almost impossible for you to make sense of all the different sensory input that's around you. So most of the time, we're going to perceive things that our goals will affect what we perceive, what we give our attention to, what's near us. There's a lot of principles that exist. Now, we know a lot about sensation and perception, just like we know a lot about the areas of the brain and their functions based on when things don't work well. So there's some people that have this thing called synesthesia. It's a neurologically based condition in which stimulation of one sensory leads to sensory information in a different sensory mode. So there's a man here in town, Peter. He actually works with Cameron Campus Ministry, Peter Marcias. And if you play the piano for him, he actually sees the sounds. He sees colors for sounds. So some people and he thought everyone saw that way. So he thought when everyone heard sounds that they would see colors. He didn't realize he was unusual that way until he was talking with someone and said, that sounds green to me or something like that. And the person went, what? And so the picture here is someone tastes in colors. So it's not a very common thing, but this can happen. And this is it's another piece of evidence that lets us know how our sensory and perception systems work together. Another fascinating, horrible phenomenon is phantom limb. And many amputees will have an issue with phantom limb. After the amputation has occurred, they will still sometimes have excruciating pain in like a leg that doesn't even exist. I highly recommend that you watch the video on the phantom limb that I have under the supplementary materials for supplementary videos for Unit 1. You'll see it'll have in parentheses next to it, it'll say optional. So these are videos like if you have time to watch, but the phantom limb one is fascinating. It's a YouTube thing. It doesn't last very long and really goes through, boy, what happens with phantom limb situation. So, okay, let's talk about the next thing. This is absolute threshold. So what do we even mean by absolute threshold? So this is the smallest amount of sound or the smallest amount of light or the smallest amount of pressure on your skin or the smallest amount of taste on your taste buds. You see where I'm going with this? Smallest amount of a stimulus that's needed for you to be able to say, I see it, I hear it, I feel it, I taste it. Does that kind of make sense? So how much light does it have to be in a room before you experience not being in a pitch black room? How loud does the sound have to be in order for you to hear it? Well, we use absolute threshold based on an individual, based on the smallest amount of stimuli that's needed for me to detect it. In other words, say it's lit, say that I hear the sound 50% of the time. So once I can detect it half the time, we're going to say that's my absolute threshold. And this will be different for different people, and it also can be different for you at different times. So let's go through some absolute thresholds. These are sort of like on average for most people, most of the time. So for sight, seeing a candle flame 30 miles away on a clear night, most of us can detect this 50% of the time. Hearing a watch ticking from 20 feet away, again, most of us can hear that, detect it 50% of the time. Feeling a bee's wing falling a distance of 1 centimeter onto your cheek. Now think about that. That is so soft, but 50% of us will be, the majority of us will be able to feel that 50% of the time. Smelling 1 drop of perfume in a 3-room house, first smelling and then tasting 1 teaspoon of sugar dissolved into 2 gallons of water. Most of us, half the time, will go, yep, there's some sugar in there. Yep, I can taste that. I don't need you to memorize these absolute threshold things. This was just to really reinforce and bring home to you what we mean by absolute threshold. You certainly do not need to memorize these. You don't need, it would not be worth your while to put these on that index card that you can bring into the exam. So remember, next week when you go to take the exam, covering chapters 1, 2, 3, and 5, chapter 4 will not be on the exam. When you go to take that exam, you'll take it at home or wherever you want, but it's closed book, closed notebook. You're cheating if you're using anything like that. You certainly cannot be taking it together as a group. You take it alone, but you are allowed to have with you 1 3x5 index card. So you can take an index card and write anything you want on both sides, and you can write on it as small as you want or as large as you want. And those are the notes that you can have with you as you go to answer the test questions. There'll be 50 multiple choice questions. None of the questions will be talking about, what is the absolute threshold for sight? And you have to say, 30, seeing a candle flame 30 miles away in a clear night. It won't be like that. I'm showing you this slide because I think it really brings home what we mean by absolute threshold. Now, what's a difference threshold? This is the smallest level of change in a stimulus that can be detected. So if we have a sound and then the sound gets a little bit louder, how much louder does it have to get before you can go, oh yeah, it got louder? That's what we call difference threshold. And then Weber's law says that the just noticeable difference is always a constant proportion of how intense that initial stimulus was. And what does that even mean? What it means is if you have a really loud sound, we'll use that as the example. So that's an intense stimulus, right? Then in order to notice an increase in sound, you're going to need more of an increase than if you started with a soft sound. So think about you're in a concert hall and no one's talking yet. The symphony has not begun, but the audience knows it's happening soon, so that everything hushes to quiet. Just a little sound, a whisper, and then someone says something just above a whisper, we'd be able to hear that difference. Because that initial stimulus, that whisper, is so faint that we only need a little bit of a difference, like a regular soft voice, not whispering, but a soft voice, and you can hear it. Now think about you go into a dance club and the sound, the music is just blaring and it's super loud. That's your initial stimulus. If you increase that sound by the same amount that you increased it when you were in that concert hall to be heard over the whisper, if you increased it by that much at this level, you're not going to be able to notice it. You're going to have to increase it more. The louder, the more intense the stimulus at the beginning, the bigger a difference you're going to have for us to meet that just noticeable difference, that difference threshold. So that's what Weber's law is talking about there. Now, some of us, a lot of us, wonder about subliminal perception. What is subliminal perception? Can we detect information that we're even unaware that we're detecting? And there was a famous experiment that went around for a long time, everyone talking about it, that was done at a movie theater. And they had set a subliminal presentation at the bottom of a bunch of the slides so quickly that people didn't even know they could see it. There was something that said something like, buy more popcorn, or buy more popcorn, buy more popcorn, or you want popcorn, or something about popcorn. And if you ask people, when you watched the movie, did you see popcorn flashing on the screen? They'd say no. But if you looked at the film, you could see that it was there. It was just so quick, they couldn't see it. And what they found was that people bought more popcorn. And so this became like famous, and we talked about subliminal perception when I was sitting where you were sitting. This is what I was taught. But it turns out that the person faked the data. It wasn't real. They made it up. And it was really hard to replicate. And now we know that that's not true. There is a subliminal presentation effect, but it's very small and subtle. It doesn't last very long, and you're sort of aware of it. It's not like if you're asked, you'd say no. It's just, you did perceive it. It's just, you didn't pay a lot of attention to it. And I've got a great subliminal video that I think you'll like. Again, in the optional material, if you look at Unit 1 videos or Unit 1 supplementary videos, and I'll have in parentheses optional, there's one on subliminal perception that I think you might like. All right, so that covers the first section of the chapter. The next section of the chapter is going to talk about top-down and bottom-up processing. And so I like to begin talking about this with this example. So right now, try to read this. Can you read this? And I know when I look at it, I can. I would say, according to research at Cambridge University, it doesn't matter in what order the letters in a word are. The only important thing is that the first and last letter be at the right place. The rest can be a total mess and you can still read it without problem. This is because the human mind does not read every letter by itself, but the word as a whole. Now, this is an example of what we call bottom-up processing. Top-down processing. It's when you use the understanding of a big picture to reason about the individual pieces. So each of these words, like this first word, according, the big picture, all the pieces are there. So rather than focusing on each letter, you used your top-down processing, you used your big picture to reason about what that word means, or what that word was, according. So it's this top-down processing is our interpretation of sensations influenced by our available knowledge, experience, and thought. If I had given the same passage to a first grader or a second grader, they would not be able to read it the way we can. We can because we've seen the word according probably 1,000,000 times. Well, that might be an exaggeration, but thousands of times you've seen that word according at this point in your life as a college student. And so you can use that top-down processing. Now, what do we mean by bottom-up processing? This is when we use individual pieces of information to make sense of the big picture. And again, in the optional videos, I have a great YouTube video. It's only like 2 or 3 minutes long that really goes into detail of what's the difference between top-down and bottom-up processing, and how sensation and perception differ from cognition. And so I think if you have time, I think that's a great way to really bring this home. Next, I want to talk about sensory adaptation. So this is an adjustment in the sensory capacity after prolonged exposure to unchanging stimuli. What do we even mean by that? Well, I love the picture of this little guy in the water. So I've started swimming in the morning at Cameron's pool just a couple of days a week for exercise. And when I first walk into that water, oh my gosh, it feels so cold to me. But after I've been there in a while, it doesn't feel cold at all. And in fact, when I go to leave the water, I'm cold now by the air. So what's going on by there? We had adaptation, sensory adaptation. My body gets used to the temperature of the water and it adapts. But that only happens because I stay in the water. If you want to do kind of a fun little experiment about sensory adaptation with your roommate or your kid or your husband or spouse or wife, friend, do this. Put in one bowl a whole bunch of ice and cold water. Put it in another bowl really warm water, not like scalding warm, you're going to burn them, but really like hot water. And then in the third bowl, put medium temperature water. And have your friend, or you can do it on yourself, your roommate, your kid, put one hand or arm in the ice cold water, one hand or arm in the hot water, and have them stay there, as long, like maybe 3 or 4 or 5 minutes. Okay, so they're used to it. Then have them take their hand out and have them put it in the medium water, and then have them do it to the other hand. And it's so funny, the hand that was in the cold water, when they put it in the lukewarm water, that lukewarm water will feel warm. But the hand that was in the hot water, when it's in the lukewarm water, the water will feel cold. And it's the strangest sensation to be looking at your hands in the same pan of water, but have both hands be having such a different experience. That's due to adaptation, sensory adaptation. Okay? Now, one big piece of perception comes from attention. What are we focusing on? What we focus on is what we're much more likely to perceive. So selective attention is when we focus on a specific aspect or experience while ignoring the others. There's a famous effect that we call the cocktail party effect, which is if you're at a cocktail party and someone says your name, you'll almost always hear your name. You'll flip around like, who said that? We seem to always focus on our names. It's something we're really sensitive to. You might be trying to listen for your spouse or your friend or your mom's voice at a cocktail party also, and you'll be able to focus on their voice more than all of the others. The next phenomenon really I find hilarious, inattentional blindness. When you're paying attention to one thing, oftentimes we'll completely miss something else. So I want to we'll see if this will work. There's no sound to the video I'm about to show you. That's what makes me think that this will work. I'm having trouble getting the sound to come through here. But let me share the screen here for this monkey business illusion. There's no sound. I want you to do this illusion. Count how many times the players wearing white pass the ball. So count the number of times the players wearing white pass the ball. Here we go. Correct answer is 16. Did you spot the gorilla? For people who haven't seen or heard about this video, about half will miss the gorilla. Did you? Here comes the gorilla. And the curtain just changed from red to gold. Now you saw it, right? And of course, oops. Okay, so let's go back to our video. So that is a great example of inattentional blindness. You didn't even see the gorilla, or if you knew what I was going to do, maybe you didn't see the curtain changing color because you were engaged in another task, and that was counting the basketball, the passes of the basketball to the people with the white t-shirt. Divided attention is when we divide mental attention among tasks. And we really have a limited capacity for doing this. Some people will say that they multitask really well. The research really is really coming pretty clear down on the side that none of us are very good at multitasking. That we do much better when we do one task and then do the next and then do the next. And when we're doing multitasking, what we're really doing is constantly shifting our attention from one task to the other, that you're not really able to do two tasks at the same time. So now the next section of this chapter is going to talk about each of the different senses, and I think that's really good for you to read. I'm not going to go into any more detail of it. I would pay attention to the study guide, and if it's on the study guide as something you should know, I would definitely find it in the textbook and make sure you know that answer. The last section of the chapter talks about Gestalt perception, and that's really interesting and great. But rather than me talking to you about it, I found a great video, PowerPoint, not PowerPoint, a great YouTube video that explains it very well. And it explains it in the way that we talk about how you can best show something graphically in a graphic design situation. So it even talks about some of the application. So I've posted that as one of the videos, required videos, even though it's not me talking. So, this will be the last video before your first exam. So your first exam is going to cover chapter 1, 2, 3, and 5. Remember, it does not cover chapter 4. So it's going to cover the history of psychology, research and the schools of psychology, and what different psychologists do, the whole field. Chapter 2 on the research methods, chapter 3 on the brain and behavior and nervous system and all that, and then chapter 5 on sensation and perception. There is a study guide that I think is very helpful. So I think if you write out the answers to the study guide, and there might be a question or two on the exam that's not on the study guide, so I don't want you to think, oh, if I know everything on the study guide, I got it all. No, you're supposed to be, you're responsible for all 4 chapters, what's in the required videos, and but the study guide will narrow down some for you. And it's a great place to start there. I also think that some of the optional videos you might find useful. I even have there posted videos that one of the other general psychology online instructor, Dr. Jeff Seeger, the videos that he posts in his Gen Psych class. So some of those you might find interesting and useful, and the way he explains things may just sometimes getting another way of hearing it can help. Most of his videos do not include visuals. The 2 on sensation and perception do, but most of the others do not. And so they're ones that you could even do while you're taking a walk, or while you're driving in the car. You could listen to them if you find that helpful. If you have any questions, please email me, maryD@cameron.edu. Good luck on your first exam. Let me know if you have any questions. Remember, once you start the exam, you'll have an hour and 15 minutes to finish it. So once you start it, you can't close it and then go back to it later. So once when you're ready to take it, has to be sometime during that week. Once you're ready to take it, that week 4, you'll find an area that you can take it where you're not going to be distracted, and you'll have your index card with anything written you want on both sides, and then you'll sit down and start answering the 50 multiple choice questions. It's cheating if you use your textbook, if you use any notes you have, if you go back and watch a video or watch it on a different computer, or if you call a friend to help, or if there's someone there, you're talking with them and they're helping you take the test and answer it. All of that is cheating. So don't cheat. All right, but if you have any questions as you're preparing for the exam, please let me know. Okay, I hope you have a good week 3, going through this information, and then week 4 is the exam. Thanks.